Yeah, everybody know that. So it's simple, which is great. Simple. Now in this section, we're gonna use a method. It's called a least square method. What the method do is determine a straight line. In some sense, that's all the set of data points when the data points are scattered about a straight line. What do you mean? How do I find that line? Right now on the exam, remember what do I do on the exam? On the exam, if I ask you to find an equation of a line, what do I give you? Something to find the slope, right? And so a point to plug it in. And give me the function or the equation. What if I don't do that? What if all I do is to give you a bunch of points, and I ask you try your best to draw a line that is get closer to all the points all at once. So if for me, I can draw a line like this. It's a line. I know it's not straight, but it's a line. Now, other student, like, okay, Mimi, I don't like that. Maybe I'll choose like this. Some other student have a different opinion. They draw a line like that. So which one is the best one?
Big one.
Huh? Because I'm a teacher. I don't know. Seriously, I don't know which one is the best one until I do my math. No idea. Right. So what I'm going to do is I'm going to draw just an arbitrary line here first. And what I'm going to do is I'm going to draw from the line, from the dot to the line a distance. I'll call it D. I call it D. In statistics, we call it error, or fancy name of error is residual. You don't have to know all that. Just D for distance, right? So here's D1, the distance number 1, because that's the point P1, right? Another one is, so here is what, D2. D3 is pretty short. D4, of course, D5. All right there. Now, what I'm going to do next, I'm going to construct a square. Is a square, all right? I know it doesn't look like a square, but just imagine they all square. Even this one is a square. I know it looks like a rectangle, but it's a square. I just don't have a lot of room. Yeah, I do like this. No, this square. If they square, what does that mean? That means this length equal this length, right? What is the area of the square? Which is length width, the same thing, which is something square, right? In this case, will be what? D, right? D. So, by the way, they all squares. They have different lengths. So, say this one length 2, this one length 1, this one length 1.5. Okay, but they all square, right? So I can find the area. I didn't know A. The area of all of the sum of this is going to be D1 squared. So that's square number 1. Square number 2 is going to be what? D2 squared. D3 squared, D4 squared, and then D5 squared. In such the way that the sum of all these is the smallest values. So whoever have a smallest sum of the squares win. I don't know which color, but here's what I found. Whoever have the smallest value of the sum of all those squares win, right? So that will be your best fit line. Now in the real world, you probably computer Python do this for you. All you do is put in the data set, give you what the best line. But of course, I'm going to show you how to do it by hand as well. So let me write something. So the best, that's that's best, sorry. This is my funny bee. The best fit line is the line that gives the smallest sum of squares, plural, bunch of squares. In this case, I have 5 squares here. Sum of squares is the line. All right. Hence, the name least square line. That's the name, right? Least square. Least square. Square is just square, like this, like literally square. Least is the smallest, right? So the smallest, the smaller the square, the smaller the sum. Right? So your equation, the graph of the equation in such a way that you can draw as small as minimize your square as much as possible. So the area is small. And that's the best fit line. Right. Now, how do I do that? There's a method. There's a formula for you to do this. So what I want is, I want to find this. But in order to find y equal mf plus b, what do I need? I need m, yeah, slope, and I need to know, yeah, y-intercept, so 2 things, right? So what I'm going to do is I'm going to give you a bunch of data points. So depend how many points I give you, that will be your sample size called n. So for example, up here, how many points? 5. So n will be 5. Right? So you know n, right? You know x because I give you points, right? You know x. So n times b. B is unknown. Remember, b is unknown. N is what you know. You know x. All you do is just add them up together and then times n. Again, m is unknown. Just leave it as n. So you know that this should be a number. And again, I give you points, so you should also know y as well. And the second equation, same thing. You know what's x r. All you do is just add them up. Keep doing that. Let me do this. Got it. Share again. Yeah. No, it's charged slower, but at least I don't have to go back and forth. Where's the battery? There you go. You know x, sum them up. Well, you know x, you can square them, right? And then sum them up again. And then on the right hand side of the second equation, it's just the sum of x times y. I know the formula, it looks complicated. It is not. And I'll show you why. I'll give you a minute to copy that down. So here's the example. What's n? What is 4? And my sample size is 4, right? In statistics, we call it sample size, so n is 4. Very good. I'm gonna do a table. Maybe it helps. So Yes, xy and y, then x squared, then x. Sum. All right, so here's x squared, y, and x times y. Why do I need those? Because the formula says so, right? I need the sum of x, sum of y, sum of x squared, xy. All right, write out what's x. Oh, by the way, these are what your x1, y1, x2, y2, x3, x3, y3. You don't have to write this down. x4, y4. So let's see, let's x first. X is 1, 2, 3, 4. And y will be what? Y will be, oh, sorry. X is 1, so x squared will be what? 1 squared is 1, right? And then 2 squared is 4, 3 squared is 9, 4 squared is 16. Now you do y. Y is what? 4, 6, 8, 11. And please be neat about this. Okay, I want them to be aligned. Maybe stick. And then x times y. So x times y. So here, 1 times 4 is 4. 2 times 6 is 12. 3 times 8 is 24. And 4 times 11 is 44. So basically, we just fill out the table. Let's sum them up. Let's add the x column. 1 plus 2 plus 3 plus 4 is 10. These will calculate if you want to. What x squared? Let's see. 10, 14, 16, 30. Y, 10, 18 plus 11 is 29. 18 plus 11 is 29. And then xy columns, 16 plus 24 is 40 plus 44 is 84. Double check with me. Sum. All right, now you plug it in, right? Let me rewrite the equation for you. I just rewrite it once. And I think the first one is n times b plus sum of x. How many x we have here? 4, right? So x1 plus x2 plus x3 plus x4 times m equal, on the right hand side is the sum of y. Of course, you have 4y. So y1 plus y2 plus y3 plus y4. That's my first equation. My second equation is sum of x times b. x1 plus x2 plus x3 plus x4 times b. And then the second one is square of x, sum square of x times m. x1 square plus x2 square plus x3 square plus x4 square times m. It helps you when you write down those, you can remember it. And then the last one is the product of x, y, and then you add them. x1, y1 plus all the way to x4, y4. I don't have space to write x2, y2, x3, y3. All right, plug it in. Let me write b and m in red so that we know this. All right, you know n is 4, so 4 times b is 4b. one down. The sum of x times n. Sum of x is this column, 10, 10, and n. Equal what? Sum of y? Sum of y, column 29. Right. One equation. Second one. Sum of x again is 10. So 10b. And then sum of x squared. Sum of x squared, the second column is 30, so 30m equal the product, sum of the products, 84. It makes sense, right? You need to solve two variables. You need two equations. Right? Three variables, you need three equations, etc. So far, so good? Do you guys know how to solve this? You should. You should. If you don't, I'll be very, very unhappy. You should. How do I solve this? What method do I use? Just give me one. Doesn't have to be the one I want, but just give me one. Yeah. What else? Yeah, elimination. Let's do that. The reason I don't like substitution because it's gonna have fraction. I don't know about you, but not a fan of fraction. It just makes things not neat and easy to make mistakes. So let's do elimination. Elimination, like the name suggests, I'm gonna eliminate one of the variables. So pick your favorite. Doesn't matter which one, but pick something that makes your life easy. If I was you, I'll pick n. Because all I have to do is multiply the first equation by what? -3, right? Because I need b2 to be opposite. So when I add the two equations together, they cancel. Right? Now, if somebody picked b to eliminate, then let's see, they had to multiply the first one by what? By maybe -10, right? And then the second one by 4, or they had to do it twice, so it all works. All right, so let's multiply the first one by -3. By the way, you're allowed to do that, right? You're allowed to multiply an equation by some number or divide by some number. Okay. -3 times 4 is -12b. -3 times 10 is -30m. -3 times 29 is 87, -87. And then rewrite the second equation, 10b plus 30. We write it in this order. Plus 30m equal 84. And then you add them together. This is canceled. It should be. This is what we want. Not something wrong. -12, +10, that's minus 2b. Equal what? Equal -3. Divide both sides by 2. B equal 3/2 or 1.5. Whichever one you can do 1/2 or 1/2, 1.5 or 3/2. Now I gotta solve for m, right? I got b down. Now I gotta solve for m. I'm gonna pick the first one again because it's more friendly. You can do the second one. The number is so big, not fan. So 4 times b. B is 3/2 plus 10m equal 29. What 4 times 3/2 equal? Very good, 6. So 6 plus 10m equal 29. Subtract 6 both sides. 10m equal 23. Divide both sides by 10. M equal 23 over 10 or 2.3. You got that. You got that. And don't stop. You're gonna plug in the equation, right? So y equal mx plus b. So the final answer is y equal 2.3x plus 1.5. Yes. Oh, the two equation? Yeah. So the two equation, I use the formula, this one. Which I copy it down here in black. So n is 4. So you okay with come up with n? Yes. Right. For the 4 points, right? Now next would be what? Something times n, right? And that something is what? The sum of all x. Sum of all x. And then on the right hand side, the sum of all y, which is. And then the second equation, sum of all x times b. Sum of all x times b. And then sum of square of all x, which is 30 times n. And then the product, sum of the product of x and y, which is yeah. It's a process. It's not hard. It's just very easy to make mistake though. Yeah, it kind of abstract when I say x1, x2, x3. Yeah. That's why I list it here for you. Oh. It's good. Yeah. Let's graph this. Let's graph this. So first, they want you to draw a scatter plot. In the book, they call it, in the book, if you see it in the book or maybe homework, they call it scatter diagram. It's the same thing. I'm a stat person, so I call it scatter plot. So do the tick mark first. See, on the y-axis, I need all the way up to 11. On the, I'm sorry, all the y-axis all up to 11. X-axis maybe up to 8. So let's do the tick mark. 1, 2, too big. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On the exam, I'll give you the one with tick marks. All right, let's see, 1, 4. Ooh, I got an idea. 1, 4. Right here. I'll do the little dot first. I'll make it a little better. What else? 2, 6. Right here. And then 3, 8. Maybe you can use your credit card or student ID. And then 4, 11. Make it a little darker. Now, I know it looks. Nobody's good at that because it looks like it's on the straight line. Most of the time it should not. It should not on the straight line. It should be like one over here, one over here, one over here. It's kind of random, right? This one look kind of too perfect. So that's your scatter plot. Part 2 is your least square line graph, right? So that you have to take a look at the part A, which is what intercept is 1.5, y-intercept is 1.5. I'll use blue here. 1.5 is roughly here. And you guys remember the rise over run? Yeah, 2.3 over what? Over 1, right? You can do 23 over 10, but I don't have 23, so I'm not doing that. So I just do 2.3 over 1. So I mean, I rise what? I rise 2.3. If I go up to 3, that's 1.5. You agree? From here to here, 1.5. One more take would be 2.5, but I need 2.3, so maybe a little bit less. Just stop like right below the 4. And then run 1. Right there. Then you grab it. Of course, on the exam, I just ask them, I'm not gonna really, it doesn't have to be perfect, okay? As long as you do the right thing, I'll give you the whole point. It's like I did on exam 1. The least square, just one line. So 2.3 over 1. You want to do that. It's good. Let's check. We can check that your I was gonna ask you. I'm gonna do something. I forgot. Yeah, I'm gonna show you how to actually don't. Let me remind you. I'm gonna show you how to solve your system equation on your graphing calculator. Well, you can check the answer. Of course, you have to show me work on the exam, right? But you can check the answer. But before that, let me show you the decimals. Right here, example 1. We do that. So those are the points. Pretty good, right? What we have. Maybe we'll do red. So what we have, just match them. And then here's a regression line. Look, we have the same slope, same y-intercept, right? So that's a line. You see our line. Well, it's good enough, right? Again, like I said, I'm not gonna take you a calculator. Everything has to be perfect, right? Let me show you how to do this on the calculator. Do you guys have your calculator with you? 4b 10m 29 10b plus 30m. Okay. Do you guys familiar with matrix? So if I were to write this, let me so my equation is 4b plus 10m equal 29. I'm just rewrite the equations. 10b plus 30m equal 84. Yeah, 84. So if I'm gonna write this in matrix, it look like this. A line here, that's the equal sign. And I'm gonna write out the constant. 29. It's called augmented matrix. And then for the, don't write this down. For these, there's going to be a coefficient of B and M, right? So coefficient of B is, the first one is 4, right? And then 10, and then 10 here, 30 here. Simple enough. So that's a matrix form. Basically, you just write out the number. Ignore the letters. Okay, all right, that being said, go to your graphing calculator. Where is my graphing calculator? It's updated, so it turned blue. It used to be pink. Okay, clear y equal, clear that. No, I don't want to go to y equal, quit. Second, x inverse. Second, and then the x to the minus 1, x inverse, you go to matrix. And go over edit. Put your arrow, go over edit. Maybe I'll pick the first, the amend matrix A. Now you have to determine what's your matrix size. What size are there? Row first and column. How many rows do I have? Well, it's gonna be always two in this problem, right? 2 rows, how many columns? 3. So 2 by 3. 2 by 3. Always row first though, okay? So 2 by 3, 2, enter, enter, and then 3, enter, enter. And then I forgot what the equation. So the first one, what was it, 4? Enter. Second one is 10. Enter, and then 29. What is it? 10, thank you. 30, and then 84. You got all that? Right, you got all that? All right, now quit them. Second mode to quit. Second mode to quit. And go back to matrix again. Second matrix. I know, make you do that. Go over math. And you go all the way down here. You see RREF. Row reduced echelon form. Press enter. Now it's asks you what matrix you want to input in that parenthesis. You want matrix A. So second matrix, second inverse, you go to matrix. Names right there, just press enter. Enter. That's your solution. 1.5, 2.3. Depend, how do I know which one N, which one is B? What the first column is a B or N? B, right? So, oh no. Yeah, first column is B, right? So B is 1.5 because you put in B first. So B come up first. So far so good. So you can check the answer on the exam, right? Just have to show me work. I'll tell you, when you guys take, if you ever take differential equation, I don't want to say you can cheat it, but I remember when I took differential equation here at OU, on the exam, we have a bunch of like solving like linear system equations. So instead of like 2 by 2, we solve like 4 by 4. So 4 equations, 4 variables, and using matrix C. And it's just a pain in the butt. It's very easy to make mistake, but you go little thing. And I can check. I don't know about other people, but I can check I got the right answer or not. So I got a good grade, but if you can check your answer, right? Just have to show work, of course. Yeah, like 3 out of 4 probably I got it wrong, but because I can check with my calculator, I can fix it. All right, so that's it. Now we go to the example, apply example. SAT verbal scores. Do we take a SAT or ACT in Michigan? Both. It's used to be both. They should still do both. Oh, okay. All right. I will. I took my high school in Vietnam, so I don't know how things go here. But okay, SAT is so mostly SAT. The superintendent of a school in large metropolitan area compile data on the students' performance on a standardized test. The following table show the average SAT verbal scores of high school seniors during the 5 years since the district implemented its Back to Basics program. So year 1, average score is 436. Year 2, average score is 438, etc. Now they want you to determine the least square lie for these data. The way the textbook, at least for the math textbook, I'm following right now, I don't like it. Because for me, as a stat person, how do I know this is at least, this is the linear data? How do I know? Like, you give me the data, and the first thing you ask me is to find the linear equation. How do I know the data that you give me is actually follow a linear trend? What if it looked like a quadratic trend, right? What if it's a bunch of points looking like that, right? Or what if it looked like a ball? We call cluster. So the first thing we do, is statistician people do, is given the data, they plot it first, see what happens. Right? If it's linear, they use regression, which is least square here. If it's not linear, they use something else. So let's plot first. For me, I like to plot to see what happened. because it's linear here. So I need you to do the math work, but always plot your data point first. So 1, 2, 3, 4, 5 on the x-axis. 1, 2, 3, 4, 5. And please label your x, your y. X is going to be years here. Thank you for the soundtrack. It's background soundtrack. All right, for the y is what? Average SAT score, right? So please label, that's 1 point on your exam. Label the axes. Oh, I start from 400 in it. So let's see. I'm gonna do a little zigzag at the bottom here. So just to tell you that I'm skipping from 100 to 400. So start out 400 here. 410, 420, 430, 440. Year 1, 436. 436, 436. Maybe roughly here. Year 2 is 438. Roughly there. Year 3 is 428. Four is what? 430 to 426. All right. Okay, looking up. Let me make it a little darker. So that's my scatter plot. Do you think it's follow a linear trend? Does it look like a linear trend? Yes, right. If it doesn't have a shape, then it's good news. It's supposed to be random, but it looks like it's a decreasing trend or increasing trend. Too bad. Anyway, so it's a linear trend, so we go ahead and find the equation. I'm lazy, so I'm gonna do this. Red. On the exam, you can do this if you want to. All right. So x is 1. So x here, I want x squared. And here is x times y. Yeah. All right, x squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And then xy, so 1 times 436 is 436. I need calculator. Six. 438 times 2, 876. 3 times 428. 1,284. 4 times 430. 1,720. And last one, 5 times 426. 2,130. And then sum of those. 1 plus 4 plus 9 plus 16 plus 25, 55. 1 plus 2 plus 3 plus 4 plus 5, 15. 436 plus 438 plus 428 plus 430 plus 426. Check with me, okay? 2,158. And last one, 436 plus 876 plus 1284 plus 1720 plus 2130. Check with me, all right? You got the right as you do. You do the same thing you do. Equation. If you don't remember, go back there. By the way, on the exam, I'll give you the equation, okay? I don't know about the final because I don't write the final. The leader course write the final, and everybody takes the same final. But for the exam, I'll give you the equation. If you have something like this on the final and he doesn't give you the formula, you just have to memorize it, and I'll let you know. And well, how many data points do I have? 5, right? So n equal 5. So 5b. So 5b plus what is that? The sum of x and m and the sum of y. So sum of x is 15m. Sum of y is 2158. Second equation. Let's see. Sum of x squared, and then xy. Sum of x is 15. Sum of x squared is 55m. And then xy is 64, 46. Elimination or substitution? Elimination, right? You can do substitution. Nobody stopped you. You just run to a fraction. What letter would you choose to eliminate? Pick smart. B or N? B, right? But it's easy. All you have to multiply the first one by what? 3 or negative 3? Negative 3, right? Negative 3. Negative 3. It's just a coincidence. I know above here we did multiply the top one by negative 3 as well. It's just a coincidence. Okay, it doesn't have to be always negative 3. Matter of fact, it shouldn't be. So negative 15b, 15 times negative 3 is what? Negative 45m. I need a calculator for that one. 2158 times 3 or negative 3. So negative 64, 74. Rewrite the second one. 64, 46. And then you add. So up here, when you add, what happened? This one cancel. Negative 45, positive 55, which is positive 10. Thank you. 10m. And plus what? 64, 46, negative 28. So m equal what? Yeah, negative 2.8. Yeah, don't bother with fraction and simplify all that. Just so that's your m. Simplify b. I'll pick the first equation as well because it looks smaller, right? So 5b plus 15 times m is negative 2.8 equal 2158. 15 times negative 2.8 negative 42. 5b minus 42 equal 2158. Add 42 both sides. So 2158 plus 42. phi b equal 2200. Move it up a little bit so I can just try to get some space. So b divide both side by 5. B is what? 440. And last but not least, your equation. Y equal mx, so negative 2.8 x plus 440. It's a downward trend. So they get worse and worse every score of the year. I hope it's not the case. I guess we should implement the back to basics strategy. All right, let's graph this. So what did the plot on the exam? Well, it doesn't matter to you. On the exam, you can plot it later. It doesn't matter. But I prefer to plot it first. All right, now you're gonna draw a line. Do not eyeball it. Okay. Some people just eyeball it. She's not gonna. No, I know, because you need to show me the intercept, right? So intercept is 440. So it's where? It's right here. Yeah. And rise over run. So rise down, right? Run over 1. So not much, really, right there. Say right there. The scale is so tight. I'm looking for a ruler. I was looking for a ruler. Right. Maybe like that. Oh, hang on. Sorry. Right, rise down to was it 2.8 and run over 1. 1 is all the way over here. 1 is all the way there. So it looks like this. So downward trend. No, but I'm gonna eyeball because you're gonna label the y-axis. Well, I'm gonna give you take mark of core, but it's up to you to label it according to the scales, right? So as long as I see the 440 there and the graph look kind of makes sense, right? Don't do this. If I know it'll be wrong. So some people just either do like that, I know wrong, right? Or like that. It just has to make sense, right? If you do like this, say somebody else do like this, maybe that's fine, right? Fine. But I look at the y-intercept. All right, but don't forget to label your axes. Assume that the trend continues. Estimate the average SAT verbal score of high school senior 2 years from now. What do I do? What do I do? Plug it in, right? Plug it in for X. What should I plug in for X? 7, right? Careful, don't look at the 2 and then plug in 2, right? Well, 2 is when X equal 2, Y is 438, so you want 7, right? 2 years from now, I mean 2 years from the 50. So f of 7 equal, what is the equation? Negative 2.8. Negative 2.8 times 7 plus 440. Negative 2.8 times 7 plus 440. 440, yeah. 420.4. we are ahead of the schedule. Well, not ahead, but we okay. We at least on time. We okay. We have plenty of time for 3.1, I believe. And we have a quiz on Monday. Next Monday we have a quiz. So my plan is 3. On Friday, we're gonna finish this section, and then 3.1, and then half of 3.1, and then on Monday we're gonna finish 3.1, and then we have a quiz at the end. Okay, so we on schedule. I don't want to get ahead or go behind. Okay, so one more thing before I let you leave. What time we leave? 47. All right, you'll be able to leave before 47, I promise. But go to all the way to the last page. I want you to get together and discuss. At the end, we're gonna answer these questions, true or false, right? So it's true, false question. So get together in group. I'll give you like 2 minutes or 3 minutes. It's gonna go to your bonus check mark. So remember your group and then put your bonus check mark. Because it should say yeah. We don't know. Yeah. No, that's awesome. Yeah, we're not going to cover today. So like if this is something you like if you feel comfortable with this stuff, I would recommend you know, like I write everything because you know, because I like so I we'll learn on Monday. Right. And I don't know because a lot of us and then we talked to the first one as well, like if we ever had that was kind of so that's what I just feel like it's like I think this one's small because I
Yeah, it's not. It had to start. Where's that at?
All right. Number 1. True. True or false? Why is it? Okay, it is false. Why is it false? Yes.
Okay, so at least line doesn't necessarily have to show a data point. It just needs to show that like
It's near the trend, right? Yeah, it's follow. It hug the trend nicely. That's all, right? So false. Second one. The error occurred in approximately n data point using the least square linear function is 0 if and only if the n data point lies on a non-vertical straight line. Error occurred in the approximately n data point using 0 n data point lie on a non-vertical straight line. Oh, hang on. Give me a second. Function be 0.
that means that has a slope, but that's not.
Did I post it wrong?
Yeah, let's see.
Error occurred.
Okay, that means
What?
What incur mean? Hang on, let me look at what's incur mean. I thought it's occur. Incur. Make oneself subject to, bring upon oneself, become liable. Okay. The process in editor using a least square linear function. If the enemy oh, yes. Yes. I got it. Okay. Because incur confused me. Okay. So what it says that I have a bunch of points, and the error is 0 if I can draw a line and all the points on the line.
Yeah, then yeah.
Yeah, right. That's what it meant. So true. Yes, true. No error. You cannot draw a square, remember? So all the sum is 0. Yeah. Yeah, just like yes. So every time you get a right answer, you give yourself one more check mark. Okay. So basically, the second question saying that imagine I can all the points lay on the line, then no area, right? No error is 0. So error 0 error. Remember what I say in statistics? We call distance is what, error or residual. So true. Let's see. I just gotta focus on it. Number 3, if the data consists of 2 distinct points, then the least square line is just a line that passes through those 2 points. True. You only need what? You only need 2 points to draw a line, right? So yeah, that's a perfect data, but no such thing as perfect data. Last one. A data point lies on the least square line if and only if the vertical distance between the point and the line is equal to 0. True. Yeah, true. If you got the right answer, give yourself on a check mark. That's all for today. We continue next time because we still have one more. If nothing else, have a good one. I'll see you Friday. Go to announcements. And you can control F to find. Say bonus right here.
Go that way.
Oh, I do more. I'll do more. Okay, I'll make this one 5.
Will the quiz be like a lot of application problems?
Hmm?
Will the quiz be a lot of application?
Likely, yeah, because
Okay.
we're going to do a bunch of applications.
That's what I was thinking. Okay. So like mostly what we've learned so far.
Mhm.
Okay.
Yes.
And it's not
Focus on the lectures. It's going to be
Okay.
very similar to lectures.
Sounds good. Thank you.
Mhm.
I'm here to pick up my exam.
Oh, you know, I think I have. Yes. Later, I left it here. Otherwise, I'll bring it home. I'll never bring it back. Thank you. See you, Lexi.
Thank you.
You're welcome.
Thank you.
You too. See you. What's your name again?
Gary.
Gary. All right.
Bye-bye.
See ya.